Hello one more time. This will be my last video that I record today, and I'm going to be going through some of the problems that I think that people are going to struggle with a little bit more from this section, being that you're not in the classroom and that I can't help you out with these in class. So the problems we're going to go through right now from the book are 8, 9, 11, 17, and 32. So let's start with problem 8. Problem number 8. There it is. Gives you a function that looks like this. And it says that they want you to estimate the slope of this graph at the point x equals 1. Well, at the point x equals 1, this certainly has a negative slope. And based on the fact that I have a negative slope, I can say that this thing is pointing downward. And I can say it looks like at this spot it's going at about 1 down for every 1 right that it's going. So I would say that the slope is -1, and that is the slope, and that's my answer. That's all there is to it. If I look at problem number 9, it's a little bit different. They want my slope at 2. Now this is something that we haven't talked about yet. This is called a corner. And at a corner, I'm being asked to find what the slope is at this instant. And think about what's happening. I'm going in a positive direction, positive direction, positive direction, and then suddenly, instantaneously, I'm going in a negative direction. Well, then what direction am I going in at this point? Am I going in the positive direction or am I going in the negative direction? The answer is we don't know. This is actually something that's relatively impossible to create in a realistic situation where you were going this way and then suddenly, without any time elapsing, you're going in this completely different, or at this completely different velocity. In a situation like this, we have what is called a corner, and that corner means that there is no derivative. So if you see something with a corner, or a spot where the function doesn't exist, etc., we would say that there is no derivative, and we move on with our lives. So that gives you 8 and 9. The next problem that I don't know why I wrote 8 here, just to practice my 8s, it's important, is problem number 11. And problem number 11 says to graph the function f of x equals x cosine of x in a graphing calculator. And to look specifically, in this case, at x equals 2. And they want you to figure out whether the slope, that's f prime of 2, is positive, negative, or 0. So we're going to look at our graphing calculator. First of all, they say specifically that we want our calculator to be in radians, which will always be the case in calculus. We will never use degrees. So we're going to try to graph this function. So we're going to go to y equals. Our function is, oops, I'm in a different mode. I want to be in function mode. My function is x multiplied by the cosine of x. So I have x multiplied by the cosine of x. And I'm going to hit zoom trig. That puts me into a standard trigonometric viewing window. And they want to know what the slope is specifically at x equals 2. At 2, it looks like my function has started to flatten out, right? I was going with a negative slope. Here, I'm switching from a negative slope to a positive slope. Let's look right around 2. So I want to set my window so that I go specifically from 1.9 up to 2.1. I'm going to have my values change by 1/10 at a time, so I'll know that the middle tick mark is going to be right at 2. That's not at all what I was looking for. Was it what I was looking for? Let's go back to the original viewing window. Why was it giving me something? Curious. I'm doing the exact same thing over again. I don't know why I expect it to change. in this situation, I can see that my function is dropping, but I don't know why it's so low. I would say in that case that the slope is clearly negative. I'm decreasing, I'm decreasing, I'm decreasing. If I change my window to go out a little bit further, maybe it starts to go back up. Let's hit zoom. Go back to the original viewing window. Oh, I know what the problem was, what my issue was. These aren't 1. So this is not 1, 2, 3, 4. This is pi halves. So that's the problem that I'm having. I was looking at this as if it was 2. And that was a big mistake on my part. If I want to trace this thing and look specifically around the value x equals 2, I want to be right around there. And in that spot, my slope is very clearly negative. So the answer to this would be negative. I'm sorry for the confusion on that, but we all make mistakes, and that was mine. So we would say that my slope is negative and be done with the problem. Next thing that they do, or the next thing we're going to look at is problem number 17, which is much more complicated. They give us the function f of x equals 2x squared. They want us to find the slope of the graph of the function at the indicated point. They want us to find the slope at -1. They then want us to find an equation of the tangent line at the point, and they want us to sketch this graph right around that point. So let's take this one at a time. Now, I'm going to find this slope by using the difference quotient, which I talked about earlier. I could also use it by estimating. So I could take, say, 2 times 1.01 squared minus 2 times 1 squared over 1.01 minus 1. This would be my method of doing this via estimation. So if I took 2 times 1.01 squared minus, that's just 2, I end up with 0.0402. So I would have 0.0402 divided by 0.01. Well, what do you suppose this slope is going to be really, really close to? The slope is really, really close to 4. So if I actually divide this, it would be 4.02, and we're looking for what this is getting closer and closer and closer to. This was the idea of estimating your derivative. But I'm not going to estimate it. I'm going to use the difference quotient so that you can get some practice with that. So the difference quotient was that thing, limit as h approaches 0 of f of x plus h minus f of x divided by h. So I'm going to take 2 times x plus h squared minus 2x squared over h, and this is still the limit as h approaches 0. This would become 2 multiplied by, if I multiply this out, I'd have x squared plus 2xh plus h squared. We get that from foiling this out, minus 2x squared all over h, which becomes 2x squared plus 4xh plus 2h squared minus 2x squared over h. And if you look at this, 2x squared and negative 2x squared cancel. And as I said in my last video, if you do this properly, all the terms without an h in them will always cancel out, and everything that you're left with will have an h in it. And that'll enable us to factor that h out. And we have 4x plus 2h over h. And remember, this whole thing was a limit as h approaches 0. And now I can plug h as 0 into this, and so I'm left with 4x. And remember, I wanted to find this as x approached, oh, it was -1, not at +1. Well, so this was wrong because I put a +1 in. So if I plug in a -1, I would get -4. And if I had plugged in a negative into this thing properly, this is what happens when I'm doing everything while I'm looking at my phone screen. I make lots of mistakes. These things happen. So I end up with that thing still being 0.0402, but down in the denominator, I would have negative 1.01 minus negative 1, which would give me a negative value here, which would make this value negative. Hopefully that helps people out. Anyway, what I've done so far is I have answered part A. I have found the slope of the graph at the given point. The next thing they want me to do is find a tangent line. Now, I talked about this in my previous videos, but a tangent line is a curve. It's a line that touches a curve in exactly one spot. Now, this is a line just like any other line. We're used to finding equations of lines. A line has two parts. It has a slope and a point. We need a slope and we need a point. Well, we already know the slope. The slope is -4. So if I put that the slope equals -4, I know what my slope is. Then all I need is a point. Well, I need a point where this line touches this curve, and it specifically needs to be at the value x equals -1, because that's where I was evaluating this at. So if I plug -1 into this, I know that when I plug -1 into this function, I get the point -1, +2, which means that I have a point at -1, 2. That's just from taking 2 times -1 squared. Well, in order to write my equation of my line, I'm just going to take y minus my y value, which is 2, equals my slope times x minus my x value. So I'll just put +1. This is called point slope form. Y minus your y value equals your slope times x minus your x value. It is way easier to find than slope intercept form. I use this all the time. It is nice and simple. You have a point, you have a slope, you're done. You don't have to worry about finding the y-intercept or anything else. And the last thing that they ask you to do is to sketch a graph of the curve near the point without using the grapher. Well, if I were to graph this line, it goes through the point -1, 2 at the slope -4. So it goes through the point -1, +2, and it has a slope of -4, which means that my tangent line looks like this. Well, what do we know about the original curve at the tangent line? The original curve and the tangent line have to be essentially parallel, which means that my curve has to be looking something like this. Well, I happen to know that this is a parabola. It's a parabola that's being multiplied by 2, and so my parabola would look something like that. That's all they want. My curve is coming close to my line, and I'm done with it. The last problem that I'm going to do for you guys right now is problem number 32. And 32 is sort of nasty. 32 asks you to use the difference quotient to find the derivative of f of x equals 1 over x minus 2. And we're going to do this using a difference quotient. So I'm going to take the limit as h, oops, I don't need a little line there. My eraser is working marginally well. The limit as h approaches 0. I'm going to take f of x plus h, which is 1 over x plus h minus 2. I'm just subbing in x plus h into this x, minus f of x over h. And my goal is to simplify this and get this h to cancel out. Again, this is something that we would probably spend a good chunk of time on in class, but unfortunately we're not in class right now, and I will talk about it enormously more next year when those of you who are taking calculus are taking calculus. But for the time being, all we need to do is some algebra to fix this and make it not look so ugly. Well, the way we're going to do that is to get common denominators. I'm going to multiply this by x plus h minus 2 over x plus h minus 2. I'm going to multiply this by x minus 2 over x minus 2. So think about what happens. In my numerator, I end up with x minus 2 minus x plus h minus 2 over x minus 2 times x plus h minus 2, that's my common denominator, over h. And we're taking the limit as h approaches 0. Let's clean this up a little bit. X and negative x, because this is a negative x, those will cancel. Negative 2 and positive 2, because this is a positive 2, those will cancel. So really I have negative h over x minus 2 times x plus h minus 2 divided by h. And really dividing by h is the same as multiplying by 1 over h. So what can we do in this situation? Hopefully people recognize that we can cancel these h's out. Bloop, bloop. And all I end up with as the limit as h approaches 0 of negative 1 over x minus 2 times x plus h minus 2. And as h approaches 0, this is going to turn into essentially just x minus 2, right? Because if this is a 0, I don't care about it. Which means that my derivative is going to be negative 1 over x minus 2 squared. And I am done with the problem. That is what we call f prime of x. As I said before, please do not get overly intimidated by these problems. There's a lot going on right now, and it's okay. If you have questions, let me know. I'll be happy to walk through some more problems. These could be confusing, and I really wish that we were in class to be able to talk about them. But this should give you a little bit of exposure, which is all that I'm looking for right now. I wish you guys all the best of luck with this, and contact me if you need help. And I will talk to you all soon. Bye.